In this video, we want to solve this logarithmic equation using the one-to-one property. In order to use the one-to-one property, we need one logarithm on one side and one logarithm on the other side. Here, since we have two logarithms on the left side, we're going to need to combine them as our first step. Notice that the two logarithms are being added together and they do have the same base. So we are able to combine them. What we'll do, since it's addition, is we will multiply their insides. So we're going to condense this into a single logarithm that still has a base 13, but inside of it, we're going to multiply x plus 4 and x plus 5. I use brackets for the logarithm and parentheses around x plus 4 and x plus 5, just so it's easier to see where the insides of the logarithm start and stop. And we carry down the right side of the equation, which gives us log base 13 of 30. Now, because we have one logarithm that is base 13 on the left, and we have one logarithm that is base 13 on the right, we're going to be able to set their insides equal to each other. So x plus 4 times x plus 5 is going to be equal to 30. So we can carry that down. And again, this is the one-to-one property for logarithms. If you have one logarithm on each side, they say I have the same base, then their insides must be equal to each other. Now, this gives us a quadratic equation. To solve the quadratic, we're going to need to FOIL out the left side or multiply it out, and then make the equation equal to 0. So let's start with the multiplying. We have first is x times x, which is x squared. Outside, x times 5, so plus 5x. Then inside is 4 times x, or plus 4x. And last is 4 times 5, which is 20. I do like to stack mine so it's easier to see my like terms. Because now when I add down, I get x squared plus 9x plus 20 equals 30. We do, again, need to make it equal to 0 so we can continue to solve. And to do that, we're going to subtract 30 on both sides. And when we do that, we end up with x squared plus 9x minus 10 equals 0. Now, thankfully, this is factorable. We need to find two numbers that multiply to negative 10, but add to positive 9. So we know that 10 and 1 are going to multiply to 10, but we need one to be positive and one to be negative so that we get the negative 10. So the other thing is that we know when we have 10 minus 1, we end up with positive 9. So that means we want the positive to be on the 10 and the minus to be on the 1, so that, again, we get the negative when we multiply, but we get a positive when we add. So that means that we can set each of these pieces equal to 0. X plus 10 equals to 0 when x is equal to negative 10, and x minus 1 is 0 when x equals 1. Now, you may be tempted to stop here, but with logarithms, we have to be very careful because there are times where this will not work because of domain restrictions. So what do we mean by domain restrictions? If we plug the number in to a logarithm and the inside becomes a negative or a 0 after you've substituted in your numbers, then it is not possible and you'll have to eliminate the solution. So let's do our two checks. Let's start by checking x equals negative 10. So when I do that, I have log base 13. And note that we're doing this in the original equation, right? So inside that first logarithm was x plus 4. So when I am checking negative 10 plus 4 is negative 6. And I can actually stop there if I want because I have a negative inside the logarithm. But just to show you the rest of it, negative 10 plus 5 for the next one is a negative 5. And we have log base 13 of 30 carries down. So again, this is not going to work out because we have a negative in front of the 6 and the 5, which are both what the inside of the logarithm simplifies to. So because that, we can eliminate negative 10 from our solutions. So it's possible that we will also eliminate x equals 1. Let's check it to see. So check x equals 1. When we plug in 1 to our first logarithm, 1 plus 4 is 5. Okay, so that's allowed. It's a positive number. It's not 0. It's not negative. And then we have plus log base 13 of, and when we plug 1 into the next one, it's x plus 5. 1 plus 5 gives us 6. So once again, we have a positive number inside the logarithm, which is allowed. So we can say, yes, x equals 1 is a valid solution. And in fact, it is the only valid solution for this particular equation.